having gone through this the links section, it will be quite helpful to you. Also, you can use it uh, at your own dispense. Okay, and just hold on for a second. Just one thing, just make sure that you understand that this is not really part of the official content, so you will not be able to find this thing in LMS. Like, so this is just my own rough work. I just like sharing it with everybody so that they can use it at their own dispense. Whenever they want to, some codes they want to refer, maybe you like my way of writing code and everything. So only then you use it. This is my own work. You can take it, not an issue. There might be some people who will be watching the recording of this session. If they want this link, they can personally message me about this, or maybe they can ask somebody else in the group whom they might be friends with, or I think there's a WhatsApp group or a distributor group also, or put it on the LMS. We will get the link through you if you want that to go. Okay, so what are we going to discuss today? Towards at the ending of the last session, if you remember, we were pretty much close to the linear regression part. We exhaustively discussed about what is linear regression and how do you go by understanding it. What are the like in which situations do you use linear regression? In what situations you do not use linear regression? We discussed about examples. We discussed about coefficients of the linear equation y is equals to mx plus c. We discussed about how to derive the value of m. We understood what is the value of c. We did those experiments in SAS also. We learned about what is simple linear regression and what is multivariate regression. I think I took a question from Navneet, I remember last time, who asked a question about clinical trials. And we understood that in those situations, how do we proceed on to doing the regression? We also understood a thing called correlation. That how does correlation pan out in front of regression? We understood that all of these methods, right, whichever we were discussing in here, right, correlation, regression, they are all a way of finding relationship between variables. Okay, between variables when we're trying to establish a relationship. Correlation is good. It can tell you there exists a relation between two variables. It can tell you how strengthful it is, but it cannot tell you that what is the exact mathematical relationship between it. That y is equal to 2x. That for every increase of one value in x, there will be a two value increase in y. So if you change in the equation y is equal to 2x, right? If you put x equals to 1, then y's value is equal to 2. But if you put x equals to 2, then y is equals to 4. Means there is a twice increment in y for every one increment in x. Correlation cannot tell you that. Correlation can at max tell you there is a relation. It cannot tell you how what is the mathematical relation behind that, all those things. So linear regression was that much. I won't say that is the end of linear regression. That is there. There is still a lot to learn. But what you learned last time is enough to get you started onto anything. It was about understanding those fundamental concepts of what a linear equation means, what a line means, how do you deduce the relationships between let's say one or two variables, and it is those in the end those p values which which are there to decide on to what is whether you keep a variable or you do not keep a variable. Now, there was this one part which we left off last time, which I want to discuss about this time is about the logistic regression part. It's very similar to linear regression in a lot of contexts, except for a couple of them. It's strikingly different than that. So the context of today's session is that we finish off the logistic regression thing. Okay? That will pretty much be the end of all of the topics which we ever had to discuss in SAS. Okay? After that, we begin by I will introduce you to the capstone project, and I will specify that what do we require from you in terms of the capstone project, what are the requirements, how do we have to go by, and all of those things. So expect about, let's say, maybe 45 minutes max for logistic regression to be understood and and then you proceed on to the capstone project after that. Okay? So, just a big background on logistic regression, a review of all of these things which we have done before. In the linear regression, we understood that linear regression is taken up in those situations where the outcome variable is continuous in nature. All right, where the outcome variable is continuous in nature. So, if you want to predict the income of a specific area, if you want to predict the amount of, let's say, rainfall in a predictable in a specific area, right? Or if you want to predict, let's say, the poverty rate in a specific area. These are all continuous values, right? You can have n number of values between 1 to 100. You can have 1.1, 1.12, 1.13 innumerable values which can exist between the two. If it comes for, let's say, poverty rate, for income, it could be anything from, let's say, 10,000 to 1 crore. It could be any value. But then there are certain situations you want to predict in which the outcome is very finite in nature. And that is what is the categorical variable does. In the categorical variables, right, the kind of situation which we have to predict is usually, one of the very few outcomes which is exist over there. So it's like, given certain conditions, would this person develop heart disease or not? Okay, again, yes or no. Heart disease hogi, would the person get heart disease? Yes or no. Given certain lifestyle, would this person develop hypertension or not? Again, develop or not, yes or no. Categorical in nature. There are only two possibilities here. Or let's say, given let's say, specific weather conditions, would there be a typhoon or not? Yes or no, isn't it? Or any situation which has only, let's say, small number of answers, usually two. Those are the kind of things when you need to predict. Those are the kind of things which you need to predict. Then you use the logistic regression approach. Right? That is what you have to prove here. And in the other, let's discuss about some more examples about logistic regression before we go into understanding the mathematical part behind all of this. Okay? There is this the logistic regression part. I would say, I worked in the pharmaceutical industry, and I've used pharmaceutical consulting and insurance consulting. The examples of logistic regression are a lot. So there is this specific thing called survival analysis. All right, you can search it on the web also. It's called survival analysis. Okay, so in this, there is a dedicated procedures available in SAS specifically which deal with survival analysis, and it is used to predict that whether a given set of, let's say, body parameters, would a person who has been admitted to a hospital, would he survive or not? Yes, we have reached that level of analytics. Understand that. So if a person comes up with, let's say, jaundice of severity level 6, let's say, or if he comes up with, let's say, HIV with a severity level of 9, maybe a couple of more conditions combined together. So would the person who is being admitted to the hospital, if you have to predict would the person survive in 1 month or not? Would the person survive in 2 months or not, or 3 months or not, or 4 months or not? These are all examples of logistic regression. So survival analysis, underneath the hood, I am pretty sure it's using logistic regression to predict the outcomes in this case. Another good example which is used in the healthcare world is about just example which I gave you. The development of heart disease, for example. So what does the heart disease really depends upon, right? So it's like, let's assume this is what we're trying to predict here, right? We are trying to predict that whether this value of PRED, right, predictive value, right, it consumes a value of 0 or 1. Let's say, okay, the only possible values of this predicted variable here, PRED, is 0 or 1. 0 means the person will not develop the heart disease. 1 means the person will develop the heart disease. So in this case, what are these individual contributing factors there? So it's like, for example, the weight of the individual. More obese a person is, more chances are that he will develop a heart disease. Or let's say another X2 variable we can assume here, X2, that is the existing case of hypertension. Like what is the hypertension values of this person? So hypertension, for all those who don't know, hypertension means blood pressure. Right? So what is the blood pressure value of this individual right now? Then we can think of like how much exercise do you do in a week? How many times? So out of 1 out of 7, right? How many times do you do? Then another variable could be, which would be X4. We can assume how many hours per day does the exercise over there. Or then another variable could be there, maybe X5, which tells us how many meals per day does a person has. Because the more the meals, more frequently a person has meals, the big meals person has, the more cholesterol, the more fried food the person gets, the more cholesterol gets into the person's body, and eventually over a period of time, there is a good indication that the person will develop a heart disease. Okay, so these are various factors. These are various factors in developing up a specific condition or not. So in this case of developing of a heart disease, right, there is no and there is nothing between developing or not developing it. Either a person has a heart disease or a person does not have a heart disease. There's nothing in between. This is the reason this is categorical. The categories only this variable can only exist in categories, and there's a reason we have to use the logistic regression part here. Not really assumptions, Kiru. I would say that these are not really assumptions. These are, let's say, okay, yeah, you can say yes, assumptions. That is, I think, it's a better word because only the p values will tell us. Only the p values will tell us whether what we assumed was correct or not. You're right in this. We can say these are assumptions right now. Okay, but usually when a researcher does a logistic regression or a linear regression part here, right, they pretty much know the hunches, right? So like, we know possibly this might be the reason. We know possibly this might be the reason that that this factor might be affecting the eventual outcome. So yes, they are assumptions, right? They are part of the null hypothesis, right? Everything in the null hypothesis is assumption, unless it is proved by the p-values in the outcome. That is what we want. So you can frame up a lot of things in life basis this logistic regression part. A lot of things. Let's say, for example, would India win a match or not? Again, match has only two outcomes, three outcomes. Let's say draw or win or loss. The three outcomes. But let's say we're only focusing on the win or loss. The draw situations are very rare. I mean, how many times have you heard about a match getting drawn in the last 1 year? Very few number of times. Let's assume, safely assume, let's just ignore that part. Let's just assume two of them. So either you win or you lose. So if you want to predict what is the batting average of individual players in the whole team, so you can contribute that in X1. So you in X1 you have the average of the batting averages of all the all the players in the team. Then you can have something for the pitch factor over there also. Then you're gonna have something for the weather factor also over there. You can have everything over here. Okay, and then finally, basis those conditions, you can predict whether the eventual outcome would be win or loss. There could be a number of other ones also. For example, would you pass in a test or not? Again, that is only dual in nature. Whether you pass or you do not pass, that depends upon, let's say, the level of study of the preparation, maybe the difficulty of the questionnaire itself, and maybe a couple of factors like this. Maybe your mood, maybe your health condition, because if you're sick, you might not be able to give the test properly. So a lot of factors do come over there, but eventually they only have this specific outcome of yes or no. All right. So the example which we will discuss about this logistic regression today also is again related to that classroom example. It deals with the example of whether given a certain factors whether a certain high score in the examination will be achieved or not. So I deliberately took up a relatively simpler example because the mathematics already is going to be quite boggling for all of us. I want at least one thing to be simple. Let the example which we take up in SAS to be simple. It's not the SAS is not class example which we'll be taking up. It's one of those examples from Bill and Melissa Gates Foundation, which they use to distribute scholarships. But I will tell you about the example as we reach up over there. Okay, but till now, just have this thing in your mind that logistic regression is used when the outcomes are binary in nature, usually dual in nature, or maybe only finite number of times only. So with just that, either a person would live or not, person would develop a heart disease or not, or would India win this match or not. These kind of situations, right? Logistic regression is the thing to go by. Now, coming on to the mathematics of the logistic regression, right? How does it differ from that of the linear regression? In linear regression, things were relatively simpler, right? In linear regression, everything is reducible using this y is equals to mx plus c. That's it. Y is equals to mx plus c. That is what we aspire for. In logistic regression, things are a bit different. You can see this part here, mx plus c. This is very similar to this part here. So this is just this is like m, and this is like c, and this is x. Okay, so this is m, c, and x. And there are other variables which are written over here, which is just part of multivariate logistic regression. So simple logistic regression is just limited to this much. So in this case, beta 1 is M, beta naught is C, and x1 is X. Simple. But these other ones are the multiple linear regression, multiple logistic regression. This is very similar to when we were doing last time when we were trying to find out whether weight is influenced by age and height both. That is multivariate regression. That is what we were doing back then. So in the same case, we want to find out whether more than one factor influences whether a person actually gets heart disease in the end or not, then it is called multivariate logistic regression. Usually, in my experience, very rarely have I encountered a logistic regression where only one factor was responsible for the outcome. It's very rare. It's extremely rare, but I mean, there's the reason I've put up a multivariate logistic regression right away over here. You need to have multiple variables affecting a eventual outcome of the spread, and basis that you drop the logistic regression part. So this is linear in nature, just like the one which we saw before. The difference comes up over here, this y here. In this case, this spread thing, right, which is supposedly equal to y, it itself is equal to what is called log of p divided by 1 minus p. And this is in the end, this is log of p divided by 1 minus p is called logit of p. Logit is the short form of this whole situation. This is a short form. Because whenever somebody writes logit, then you can expand it into log of p divided by 1 minus p. Alright. Firstly, what are these things? Okay. The log here is the log of base e. Alright. Does everybody understand what does log of base e means? Does everybody understand that part? Yes or no? Logistic. Okay, I presume the rest of you also know that. All right. Okay, so just a quick reminder here. Whenever you have to take up a logarithm log of base e, this is what's called the natural logarithm, and so in just natural log calculator. So I mean, this is the number. This is the number. You just need to remember 2.718. This is the value of e basically, and no, Kiru, that cannot be considered linear because of this situation. That no matter what this is, we have this beta naught plus beta 1 x1, right? But in front of it, it is still log of p divided by 1 minus p. So still we are not predicting the y variable here. Okay, we're still predicting this log of p divided by 1 minus p. Okay, we cannot assume it is linear still. But I'm just saying in logistic regression, very rarely just one variable influences something else. Usually there are more. So I wanted to show you that. Yes, I think it should be able to tell us about it. At least something. Yes, this is what I'm speaking about. This log of base e means this e thing over here. The whatever is the base of this logarithm, right? In the end influences what will be the value of y here. So if you take log of base 2 of a number, its value of y will be different. If you take what is the log of base 10 of x, its value of y would be different. Okay. So log of base e is called a natural log, and the value of e in this case is 2.718, as I just showed you. And you can experiment on your own that what differences does come up when you choose different bases of log. Different base means remember those log tables which we used to do as kids. We used to have those log tables in those pamphlets, right? That was log with base of 10. that we used to do over there. So you can choose any one of them whenever you're doing the calculation, as long as all of the calculations are made with the same base. Okay. So in this case, in logistic regression case, the one which we take is the 2.78 value, the log with base e, as the one to do all of the calculations. Okay. Other ones are not used. Again, there are reasons behind it, but we need not get into. Let's just learn what happens when we choose log of base e here. So it is this about log of base e that is used, and this is p divided by 1 minus p here. Okay, now the next question rises is, what is this p here? Okay, what is exactly this p? If you know what, I mean, if you let's say try to think of it this way. He firstly, this p values, this p actually means a probability. Okay, this does not mean the p values that are an outcome of SAS. Okay, just this is a very important point I need to understand. The p values which you get in the coefficients are different than the probability values that are listed here. Okay, this is very important part here. Now, what are these p values basically? This p represents the probability that eventually the pred value, right, will be either 0 or 1. Okay, let me explain it a bit more further. So p in this case means whether a person will get a heart disease or not. So in this last thing they said, heart disease or not, usually only one is chosen. So you say p is whether a person will get a heart disease. That's it. P is the meaning of that thing. So probability that a person would get a heart disease, okay, is given by log of p divided by 1 minus p is equal to beta 1, beta naught plus beta 1 x1 till beta n x1. Alright. So log of p divided by 1 minus p means that whether the specific value of pred here, right, which is equal to this, will turn out to be of a specific case. Okay, whether a person would get a heart disease or not, whether India will win, whether a person would get a heart disease, whether a person would develop hypertension, whether it will rain, whether, let's say, whether whether it will be sunshine today, maybe, or whether will my fuel be all consumed in this trip, just like this. So you choose one of all of the possibilities of the outcome variable, and you choose one of them, right? When you choose one of them, and then you say this probability is the probability that that outcome will be of that specific kind. That is what the logistic regression actually means here. Okay? So I think it will be more clear if I describe to you, graphically what does this actually mean. Uh, so this log of p divided by 1 minus p, this is what it looks like. Okay, this is the graphical outcome of this log of p divided by 1 minus p here. So this p in this case is just written as x. Okay, this is only for notational purposes. This x is not the same x as this one. This is not. It is just that this graphing calculator doesn't allow me to put p here. It doesn't allow me. It just tells me that all I can do is have the outcome as y and the input as x. This is the reason I have to choose x instead of p here, which I'm writing here. But the graph nevertheless will still be the same. So log of x divided by 1 minus x, just see the graphical values here. So you can see the basis this, what are the eventual values of y? No matter what the value of x is here, right? What is the eventual value of y which is existing in this? Look at this. No matter what the value of x is, right? Okay, its value is always lying between 0 and 1. The outcome value of y is always lying between 0 and 1 here. Okay, I can zoom into this. You will see it will never overlap. It will never ever overlap anywhere at all. It just looks like it is overlapping this one value here. I'll zoom out right now. So it looks like this value of x, which is equals to 1, that y has overlapped the value of 1, but no, if you keep on zooming into this, you will never see the overlap. You can go to any bigger value of x also. I can keep on going up. Look at this. All right, still more zoom, I believe. Okay, no more zoom available. You know what I mean? But this is not overlapped at all. Okay? The reason now, what you need to look into the reason here is why does it never overlaps it is because consider the value of x here. Okay, what could be the value of x? What could it maximum vary to? If I put x value of 0 over here, then yes, I get log of 0, okay, which is that's still not calculable, but yes, it reaches infinity. You can say that. But any value which lies between 0 and 1, x can only range between 0 and 1 because just try to look at this. If I put x equals to 2 here, then it becomes 1 minus 2, which is minus 1. So it becomes log of minus 2, which is not calculable. There's no logarithmic, there's no logs of negative values, there's only logs of positive values which you can create. So this is the reason the value of x can at max vary between 0 and 1 in this function. So that the end value of y can only range between 0 and 1. And this was a strategy, probably the people who invented logistic regression used, because the probability also, as you have told you before, can range between 0 and 1 only. It can only range between 0 and 1. Probability can never ever be less than 0, or it can never ever be greater than 1. So they needed a function, which pretty much encapsulates this thing, this whole logarithmic, whatever is within this log value here, right, has to vary only between 0 and 1, right? And when a log is calculated, the outcome also should be the outcome also should be of a finite nature. So no matter what the value of x is here, right, the value of uh, you can see this, there will never ever be overlap of the y values onto this one at all. So y for x is equals to 1, x equals to 1 here, right, there is no existent value of y which can exist. So it can only be very close to this, very close, but not exactly equal to, there's no value of y when x is equals to 1, because 1 divided by 0 is infinity, and log of infinity doesn't exist. So x value of 1 means the probability of getting a certain disease as 1 exactly 100% doesn't really exist in logistic regression. The only estimates we can draw that 99.99% probability is that the person will develop a heart disease, but not 100% possibility. And that pretty much also confirms our uh, uh, you know, understanding and thought process that in statistics and probability, right, there is nothing like getting 100%. It's not really possible to predict the future and say everything is possible 100%. So a person will get a heart disease. It's not, the logistic regression cannot predict it 100% of the times, but maybe certainly less number of times it can still predict. ठीक है, तो I know कि this would have already been a bit overwhelming to all of you. ठीक है, so I'm going to repeat this thing once again. And I know again I'm habitual to doing this because it takes a while to get along with logistic regression. It's a bit difficult thing to come by. ठीक है, so the I hopefully I presume so that everybody understands the examples behind the logistic regression. You use a logistic regression only when the outcomes are finite in nature. The outcomes in this case, which is y, the y as the variable, it is only certain outcomes, means whether we are tracking whether the person develops a heart disease or not, whether the person develops hypertension or not, only dual kind of an outcomes. Okay? So to tackle those kind of situations where dual outcomes, we cannot use linear regression. Okay? Because linear regression is built for continuous data. When we are trying to predict incomes of a person depending upon, let's say, the education status or the socioeconomic status or the gender, or maybe some background of the parents also, that also helps for a person to get a good job and maybe higher salary. So that is continuous in nature, but not here. In this case, we have to use the logistic regression to predict those kind of values. Now we understood that in logistic regression, the two parts of the equation, right? The right side of the equation is very similar to the linear regression part of the equation. It is very similar. But the left hand side of the equation, which is this spread, which is equals to log of p divided by 1 minus p, that is very different from the linear regression part here. Because in this case, we are not saying ki y is equals to, we're not saying that, this is y. We're not saying this is y. That is not what we are saying. We are saying that this instead of this y, this is what it is equal to. Log of p divided by 1 minus p. Now, what does this log of p divided by 1 minus p actually means? It means that whatever we are trying to predict here, okay, whatever we are trying to predict here, whatever is the outcome variable in this, what is the probability that the outcome variable will be of one specific kind? That is all that we're trying to predict here. So in terms of heart disease, the probability here means the probability that a certain person will develop a heart disease. That's it. The probability that India will win the match. That is it. And when I drew up this graph here, right, this is what I wanted to show you, that this is the equation of when I plotted over here. So what are the possible values of the outcome variable here? This is just look at this right hand side part here, x divided by 1 minus x. The most interesting element about this whole plot is that the x can only range between 0 and 1 here. And this is like the reason I told you, because of the way logarithms are calculated. For any value of x greater than 1, okay, greater than 1, the result of this equation is negative number. If we choose x equals to 3 here, 3 divided by 1 minus 3 is minus 1.5. So log of negative numbers do not exist. So this whole thing becomes incorrect. So we cannot use it. We cannot use x value. We cannot use x value of negative. Isliye there's no value of x going beyond 1 here. You also cannot use the values of x which are less than 0, because if you choose the values of x less than 0, again the outcome of this equation x divided by 1 minus x becomes negative. So we choose minus 3 here, so it becomes minus 3 divided by 4. 1 minus of minus 3 is 4. Minus 3 divided by 4, that is minus 0.75. Again, you cannot calculate a logarithm of that. This is the reason the x values will never vary out of 0 and 1 ever. So only it can vary between 0 and 1, where it yields a positive number. Okay, and in those situations also, we see that the value of y, which is the outcome variable's value, okay, it will never ever reach 1. It will, let's say the value of y can have any value, but the value of x, when x is equals to 1, right, there will be no value of the outcome variable when x is strictly equal to 1. It can never have that value. It cannot have that value at all when x is equals to 1. Now we understood that this x divided by 1 minus x is very similar to this x here, right? This has the same properties as that of the probability variable. Whenever we calculate the probabilities of anything, we know that its value can also range between 0 and 1. And this exactly explains what was the inspiration behind the creators of the logistic regression, behind choosing the logistic function to describe the logistic regression part here, because they understood that logistic regression can pretty much tackle for those kind of possibilities where the probability of getting a specific condition, like getting a heart disease, can be tackled using just zeros and ones, nothing beyond it, and the corresponding value of y can adjust according to the values of x which have been listed over there. So the thing which you need to understand here is the log of p divided by 1 minus p. If I were to write it here, this is what it is equal to. This is what it becomes equal to over here. Let me just show you how does this thing look in SAS also, and I choose this oh, that's weird. Yeah, so in proc logistic also, right, things are pretty much simple in nature. So this is what I'm speaking about. So you can see in the proc logistic, right, the equation, the thing which we will be discussing is the example which we will be discussing in a short while is we will be predicting the high scores of the individual of the people. We would simply predict the basis the gender of the individual, right, and the scores obtained in a couple of more subjects. Okay, whether it is a sufficient predictor of a high score of the individual or not. I'll explain the pretext and the context of this specific thing, but high scores we will be predicting. We will not be predicting the exact value of high score. We will not be predicting is 190, 160, 140 or not. No, that is not what we will be predicting. We will be simply predicting whether it will be a high score, that is one, or it will not be high score. That is zero. That is all what we're predicting. So in this case, log of p divided by 1 minus p becomes the probability of the probability thing in this case. This p value, a probability, means whether a high score value will be equal to 1 or not, whether this whole model as it is made, whether it will achieve a high score or not. That is all that we are trying to predict there. That is the probability that we want to predict there. Now there is one more mathematical thing which you can draw out from this thing is, in some of the situations you might be required to create up this probability. You will be asked what is the exact probability depending upon these values of x here. You will be asked what is the value of p here. Right now the situation reduces to solve for the value of p. Like in school they used to ask us solve for the value of x, right? In this case the situation becomes solve for the value of p, right? How can we express p in terms of everything else which is there in the equation? Okay, so what you need to do in this case is this is actually quite important, because this leads us to this sigmoidal curve as I have listed here. Uh, this thing, it will lead to this, the logic curve, sigmoidal curve with the graph, and this will tell us about posterior probabilities of the function, of the sigmoid function. That is what we will be trying to derive here. How do you reach this? How do you solve for p in this? So this does require a bit of a mathematics, and I'm not sure this requires a bit of high school mathematics, not the pre-10th one. So I'll try to explain this thing as much as possible, but do tell me if you don't, I'll repeat it. So in this case, log of p divided by 1 minus p, this is the equation which we have here. What we're trying to find out is we have to express the whole equation in terms, we have to express p in terms of the rest of the equation. That is what we're trying to do. So in mathematics, what you can do in this case is that to convert this equation into a normal form, you multiply both of these sides by e raised to power x. Sorry. If you multiply, so I think let me explain it this way. So what you can reduce this equation of this form is that you can write this equation as p divided by 1 minus p is equals to e raised to power the same value. This is what you can describe it as also. All right, you can describe it this way. Now, how does this thing log transforms into this one? For me, it is very natural, because it is something, it is a known thing that the log, when taken to the other side of the equation, changes to the e value raised to power the rest of the other things. So now, if I want to solve for the value of p, right, what would you do? This is p divided by 1 minus p here, right? I'll take the inverse of both of the sides of the equation. I will do 1 minus p. Okay, this is 1 minus p divided by p is equals to e raised to power minus of this. All right, getting it? Now this is minus of it. This was e raised to power only, but when I flip the both of the equation, when I exchange the numerator and the denominator here, right? Then I have to inverse e raised to power minus. Then this becomes inverse. This becomes 1 divided by e raised to power this, which is equal to e raised to power minus of beta naught plus beta 1 x1 and so on and so forth. So the left side of the equation now can be reduced to 1 divided by p. Okay, I'm just solving for it. 1 divided by p minus 1, because this p over here, right, comes underneath this. This becomes 1 by p minus of p divided by 1 by p divided by p is 1. This is the reason of minus 1 here. So again, this thing is equal to like this. Okay. Now I can just simply add this. 1 by p is equals to 1 plus, just taking this minus 1 towards the other side, so it becomes 1 plus this value again. Okay. All right. So now we have 1 divided by p is equals to this side of the whole equation. This is what we have. Now, just again reverse the numerator and the denominator here. Again, just reverse the numerator and the denominator. So when I exchange it on the left hand side, it becomes just p, and on the right hand side, it becomes 1 divided by this number. This is what it becomes, and this is the value of P here. So this is P is equals to 1 divided by this number, 1 divided by 1 plus e raised to power all of these individual factors. So this P now can exactly be deduced. This P was the probability that the outcome variable will be of a certain kind. It means that the person will develop a heart disease or hypertension, or the person would get a high score or not, and things like that. This is what the value of P tells you here. And now you can exactly calculate it. And for demonstration purposes, I've plotted it over here. This is what it eventually looks like. So just try to compare this equation. So this P in this graph I've written as Y, okay, because I told you there's a limitation in this Desmos that I can only use Y and X, okay. So P is in this case written as Y, 1 divided by 1 plus e raised to power minus something, whatever it is. Okay, this is what I've written, e raised to power minus this x here. Right now I'm just considering one outcome variable. That is what one predictor variable, one independent variable which is influencing y. So if I look at the graph here, this is what you will notice. Alright, this is what is called the sigmoid graph of the logistic regression. The p values here, you would notice, since y is p in our equation, probability cannot range out of 0 and 1 at all. And this is what you get here also. The probability cannot range beyond 0 and 1. No matter what the value of x here, no matter what you put the value of x, right, you will see it will not quite overlap. It will not quite overlap 0 or 1 at all. So no matter what the value of x here, no matter how negative it is, no matter how positive it is, the y value will always range between 0 and 1. Strictly, 0 and 1 will never really be achieved. They will be achieved only at infinity. Alright, that is not something which is considered in math at all. The infinity is a very interesting number. There's even a movie made on that. The Man Who Knew Infinity, Ramanujam. He gave the concept of infinity. So, but yeah, infinity is not really a known thing in mathematics, so we don't really consider it. But it establishes a very core principle in statistics and logistic regression that p values can never range out of 0 and 1. They can be equal to 0 1 only at infinity. We can assume that this line meets the x-axis only at infinity, and this green line meets this y value of 1 only at infinity. Okay, so no matter how much you increase the value of x, the value of y will be closer to 1, but it will never be 1 unless it is infinity. Right, so this is what's called a sigmoidal curve of the whole probabilistic function. This is what was being described here. This S-shaped curve is the signature curve of logistic regression, and this S-shaped curve tells you what is going to be the probability of getting the outcome variable of a certain kind. That is what will be, let's say, predicting in this case. All right. So I know we've discussed this thing twice now, right? But I mean, I just want to ask everybody: are they getting this? Are they getting what is the core fundamentals of logistic regression? What is the mathematics and the graphical nature of a logistic regression is? Are you getting it? Hiru, Priya, what about the others? Hiru, Priya, anything? All right, great. So, my intention is, I could have just simply done away with this thing. I would have just ran this whole solution to you and would have said, this is the way you see it. But I would not really want that thing to happen, because most of the things which I told you here, right? These are straight away questions from the interviews. They will ask you what is the sigmoidal curve in logistic regression. They will ask you what are the range of the sigmoidal curve in logistic regression. The answer is 0 to 1. That is the maximum range of this sigmoidal curve. It can never be less than 0, but it can never be greater than 1. You can only approach zeros and ones, but all the values will be like this. They will ask you in this what do the value of p in this predicts. They will ask you this. What does p tell? What is p in this? They will ask you this probability. They'll ask you, are these the p values? Your answer is no. You have to tell them ki p is the probability that the outcome variable will be of a certain kind. And if you want to derive it, ki what will be the exact value of the probability, then this is what we have derived it already. I'll just share it with all of you so that you can look into this mathematics at your own side also. The first part of it, this is the part which not many people might know about. The log can be transformed like this also. I just want to do away with the log part here, so I can use things like this uh, on the other side of the equation. So this is a normal transformation. This is called a log transformation in mathematics, and I don't know how many people you might be aware of it, but this is taught usually in engineering and or in the high school mathematics also. In those differential equations, right? It becomes quite important to understand that. But this is all about it. Okay, so we now know the mathematics behind it. Okay, we know the mathematics behind it. We knew the reasons behind why do we calculate the logistic regression also, and we also have somehow been able to describe it in a form of a graph also. So just one last thing, so that you don't end up confused. These are the two things which I showed you right now in the form of a graph, right? They are actually the same thing. If you would try to look at it, if you try to, just with this curve here, right? This red colored curve. If you just were to, let's say flip it, uh, let's say 90 degrees, you rotate it 90 degrees and then you flip it, it will be exactly this graph which I'm seeing here. This is exactly the same thing. So both of these equations were, let's say, one way of saying the other thing. These are one way of saying the other thing. And the more important point was, what is the range of the values here in these cases? The range in the green line case is 0 to 1, just like in the case of red, which is again 0 to 1. X can range between 0 to 1 here only, and which is P, by the way, which was P, correct? In this case, it was red case, it was P here, P divided by 1 minus of P, which we're trying to predict here. In terms of green line, it is the P comes now here. P is now being described in terms of the rest of the equation. So P again has to have values of 0 and 1 only, between zeros and 1. This is the reason the green line only varies between zeros and 1. Just like it before, it was varying between 0 and 1. So this was pretty much the same thing. It was just, जैसे होता ना कि as you say कि कान को एक साइड से पकड़ने लेकिन दूसरे उल्टे हाथ से पकड़ लेना. It's the same thing. As what we saw there, but it was necessary for you to for you to understand what is sigmoidal curve. How do you calculate that exact value of the probability? So this is the part which is used as it is in logistic regression, but this is an extra step. This is just an extra step. This green line is just an extra step that you might perform if you are asked to calculate the exact probabilities in this situation. If you want to calculate the exact probability. Okay. Let's see an example right now, okay, so that it becomes a bit more clearer after that. Okay. So this example, just a context to give you what is this example derived of. Let me just describe you the data set first. So this is a data set right now. Just try to observe the values listed here. So it's like the ID is definitely just the row variable. So one is the gender, female, but try to look at what the possible values in this. So gender can have only values of zeros and ones here. So 1 means it is a female, right? 0 means it is male. Okay. Then we have the marks for physics, chemistry. Then we have the marks for math, and then we have a value of high score. We say that the value of high score can only be value of zeros and ones, right? And in this case, the high score is defined as any value which is greater than the value of 150. If the aggregate values of the marks obtained in physics, chemistry, and math, right, they aggregate to be more than 150. Alright, if they aggregate more than 150, then it becomes a high score. Otherwise, it is not really a high score. Okay? In this case, you can see for 148, it is not a high score, but for let's say 152, it is a high score. So 150 is the cutoff marks in this. Now, what are we solving in this? What is the purpose of doing this specific example, and what do we have to take away from all of this? So this, as far as I remember, this is from one of those Bill and Melissa Gates Foundation. It's a non-government organization. They do some really great work in African countries, including also in India. So what they wanted, this is the data set derived from their, you can say, let's say their research and what they were trying to do at their end. So Bill and Melissa Gates Foundation gives away scholarships to women who have the potential okay, who have the potential of being successful later on because of, let's say, their intellect and intelligence in this specific, let's say, academic examinations. Because of, let's say, if they're intelligent, they will score good, which means they have a higher potential, so they should be given higher scholarships for all of those things. Now, what the purpose of this thing in all of this situation was that we wanted to predict, okay, what was the relationship which we were trying to establish in this. In logistic regression, we were trying to establish up a relationship that whether is there a relationship between high score, okay, obtained by an individual in this data set and the marks obtained in individual subjects and the gender. Okay? So gender is definitely one. In this, female is the one which we're considering. There is physics, chemistry, and math. Now, what we want to understand is that we have to include the female variable in this. We have to include it because that is what they were trying to look for. Whether women, right, they can be clubbed with the marks obtained in certain examinations, and then can we say is there a relationship between the two? Can we say that in a certain district or an area, women are excelling in a specific, let's say, a specific subject or a group of subjects, okay, so that we can predict that they will get a high score, right? Even not just now, even in the future, if any examinations are conducted. Getting it? So, आज physics, chemistry or math के अंदर if they hold examinations, there might be a relationship that women might be outperforming men in certain subjects. Okay? So these women should be given scholarship because in the future also they will be outperforming men, okay, and getting high scores again. And that is the purpose of giving them the scholarship. That it should, act as a enhancer or as a motivator to study more, to read more, and reach high up in life. So we're simply trying to find out is the relationship between gender, okay, and the marks obtained by that gender, and whether that led to a high score or not. Okay, that is what we're trying to establish here. Simple. Okay, so that the Bill and the Melissa Gates Foundation can give them the you can say the scholarships or not here. So when I will run this logistic regression equation here, okay, let's see the outcome as it comes by. So in this case, let me just describe to you. Yes, just look at this. Just look at this here. So right now, I just the code which I used was I was trying to establish a relationship between high score obtained and the gender, okay, and the marks obtained in physics and math. So what this try to establish up a relationship that if it's a female, are women consistently consistently scoring high in physics and maths here? Consistently high score such that these two marks were enough to get them past the 150 aggregate marks at all. So they're going to give the scholarship basis. The Bill and Melissa Gates Foundation are going to give you scholarship, right? If you are a female, okay, and you scored high score marks, okay. What they are not sure of as yet before performing logistic regression is whether there exists a relationship, actual relationship between women and their marks obtained in two subjects, okay. Whether there exists a relationship between these two things or not. Because if this relationship is established, they can be sure that they can use this relation here to be sure that these women will be taking up science courses or mathematics or physics courses or engineering courses in the future, and whoever they are given the scholarship, it will be worth the money. Okay. Getting it? Does everybody gets the problem statement here? Does everybody gets it? We're trying to find up a relationship between gender and the marks obtained in certain subjects, so that we can be sure that if we were to say that okay, okay, let me just redescribe this question so that it might be more understandable. If imagine if we were looking at only of these PCM scores here, right? Physics, chemistry, and math. That is what. So what they would have done is they would have simply looked at who has scored up a high score in this. Okay, whoever has scored up a high score in this, let's give her a scholarship. If it's a female, okay, if it's a female and if she has scored, let's say, high marks in this, okay, if she has scored high marks in this, so let's give her the scholarship, okay. But that's fine. That's one nice way of doing it. That is the way the world works, right? If you get the high marks in this, you get a scholarship. But what they wanted to know was, what they really wanted to know was, it could have been just this examination, just this one examination, in which women would have scored high marks here. Like just like those entrance exams, just like those, scholarship exams which we have all given as kids, right? It is just one examination on basis of which all of our talent and all of our skills and ability is reduced. And we all have found ourselves ranting about this, that this is not the best way of doing it. It was just that one day and three hours of that question paper, right? We decided all our fate. That is not right. Right? This is the same factor which Bill and the Melissa Gates Foundation wanted to avoid here. They wanted to find out, कि ठीक है, it could have been just this one paper in which, this is the pattern in which certain women have scored high marks and certain women have scored less marks. It is just this one paper. But if we are able to establish a relationship between the gender and the marks obtained by that gender in a specific group of specific subjects here, if we're able to exactly establish a relationship between this, then we can say that probably this is not happening because of chance. It is not just because of one paper. Probably it is that women in that specific district are much more inclined to getting, reading about physics or maths, and this is the reason they're outperforming men. And it will not be just this examination whose outcomes have been this course, right? It will not be just this examination in which they outperformed men. It will be consistently in other examinations also that they will be outperforming men. They want to establish that relationship here. That is what they want to establish as. And once they've established that relationship, okay, only then they want to give out scholarships basis that outcome. Okay, isn't this fair? Isn't this a fair method of doing it? It could be just that एक examination, why just one examination decides on to the fate of an individual? Okay, but is there a relationship between, let's say, the gender in this case specifically and the marks obtained by that gender in two subjects, that we can say yes, there exists a relationship between these two, this gender and the marks obtained, and that gender will outperform the other gender consistently in the upcoming examinations also. That is what the purpose of this logistic regression was. Simple as that. Okay, and when I run this, and the marks which we obtained here, right? Again, the most important thing here uh, is this outcome which we got here, right? So in this female physics and math, right? This is again the same things which we did before. The estimate part here is the one which you can see here. The intercept is the value of minus 32.9225. So yeah, just look at this. So in this case, the intercept value of minus 32.925 is this value. This value of beta naught here. This female, it is 1.5019. Okay, it is this beta 1 here, and it is x1. X1 is female. The values of the female variable, which is only zeros and ones. Physics is 0.3992. Again, this is beta 2 x2. The beta 2 is 0.3992 multiplied by the marks scored in physics, and same thing goes for the mathematics also. The interesting thing here is these p values here. Now look at these p values as we see here, right? So these p values, as we discussed, in the previous session also, right? The p values have to be less than equal to 0.05. Only then they become significant. Okay. So just try to look at here, right? So it becomes significant for math. It becomes significant for physics. Means physics and math does influence the high scores, which was expected. So does the intercept. But look at this female value here. It is 6% approximately, or 0.06. That is, it is, very marginally above 0.05. So what you can say is, in this case, depending on the outcome which you had here, right? Females as a gender doesn't really figure out in this case, that females along with physics and maths do not really qualify as a good indicator that a high score by that person would be achieved or not. But somehow, you know what I mean, when you get values this close to 0.05, you don't really like to reject it. No, you don't really like to reject the null hypothesis that, that the female variable does not influences the outcome. Nahi. You still can give it a benefit of doubt and say that maybe this is, because of, let's say, maybe just the randomness of the data this has came by. So I would still like to include that the gender clubbed with the physics and the maths marks, yeah, right, does influence the high score. But now we can only say this thing with 94%. Previously, since it was 0.05, since it was 5%, 100 minus 5 is 95%. So I could have declared my results with 95% certainty before. But now I'm choosing, instead of 5%, I'm choosing 6% as my cutoff mark, cutoff point in the value of t. Usually it is 5%. I am doing a sin by choosing 6%, but for the sake of it. Now, you can say कि इतना चलता है. मैं नहीं इतना चलता है वो वाली चीज है कि 6% as the cutoff here and 94% is the confidence which I can say that the gender and physics and maths is influencing the high scores obtained by the individual. So what does this outcome actually means now? Now what does this mean basically? We know the value of physics and maths, and we know the gender kind of, the women are consistently getting more marks in physics and maths here, right? So what does this basically mean? This means that we have established a relationship between, women getting high marks in physics and maths. Because women getting high, there is a relationship between women getting physics high marks in physics and maths, which leads to your eventual high scores at an aggregate level. Okay, there is an influence of this, and what this means is, right, there is this very popular terminology which is used. It's called these STEM subjects. It's called the science and technology, engineering and mathematics. So there is a worldwide push on people to choose these subjects, okay, for the betterment of the society and choose up a great career and everything. Science and technology, engineering and mathematics. So Bill and the Melissa Gates Foundation, since physics and maths are omnipresent in all of these things, they'll always be omnipresent. So they wanted to know ki basis the marks obtained by individual females in physics and maths, yeah, right? They should be alone be considered as a good indicator that the women will go on to pursue the let's say the STEM subjects. Okay, चाहे they pursue chemistry or not, चाहे they pursue arts or not. No, they could choose arts, chemistry, or they could choose commerce. They could choose anything. Okay, but physics and maths and the gender of the individual is enough to predict that there is a very good chance that if we give the scholarship to this individual, then she will go on to pursue the STEM subjects. And that is what the purpose of the Bill and Melinda Gates Foundation was. They were not looking for just the aggregate of these two subjects, physics and maths. They were not looking for it. They were not also looking for conducting one examination in which decides on the fate of everybody. They were just looking for the relationship between the physics, maths, and the gender of the individual. Once that is established, and if it is established, then basis the marks obtained by women in physics and maths, right? They will be used to distribute the scholarships over to them. So this is what you get out of it. This is one of those examples, which exists for logistic regression. Okay. I didn't choose a for example for which is concerning, let's say, pharmaceutical or healthcare or finance or that, because again it alienates a lot of people because they might not be from that domain. But I would encourage you that as you try this thing at your own dispense, right? Try to download any data from the web, right? And just it is as simple as this: the prog logistic code in SAS. That you just write this thing here, right? And when you execute it, just look at those p values in the end. Right? They're the deciding factor whether that influences it or not. So if somebody among you is from healthcare, right? Maybe, or maybe somebody's from sports, just download the relevant data and just combine it all together. Just make sure that the outcome here has to be just maybe, one of the many possibilities, or maybe best is two, just two possibilities. That is what you're trying to predict here. Okay. Does everybody understand this example? Does everybody gets it? Everyone? All right. So I see. The less number of people have telling about. Just tell me again. Do you understand everything, or should I repeat something specific? Priya, Saurabh, or anybody else? Navneet? Okay. Maybe I think maybe people are gathering their thoughts right now. Maybe I think in a short while we'll head out for a break. Also, maybe after that we can understand your questions maybe again. I just want to explain to you okay, what is this proc logistic example, like how do you write this proc logistic thing in SAS? So you can see it is very similar to this proc reg thing here. Let me just copy paste this. Yeah, just look at this. It is exactly similar to this. It is proc logistic and then proc reg. Then data is equals to input dataset. Data is equals to input dataset. Then it is model, and then it is the outcome variable, which in this case was weight, as we're trying to predict in reg. And then these are these individual independent variables, contributing variables. And in this case, it was height, and then run finally. There is just one extra thing of descending here. Right? This needs to be explained to you. What does descending means here? Okay, so this descending thing, just look at the outcome which we achieved here. And yes, just look at this line here. Probability modeled is high score is equals to 1. So what this descending does is, the high score value, okay, we know that the high score value can be of just two types, it is 0 or 1. When I said descending, okay, so by descending, I was making sure that the, that what I'm trying to predict in logistic regression is that you will get a high score. Okay, because getting a high score means value is equals to 1. And this is what this outcome also showed. Probability modeled is high score is equals to 1. That basis this code here, right? Whether these three factors, right, actually lead to a high score. That is what I was predicting. Okay, that is what I was predicting here. Right? Again, I will explain it. There are two possibilities in this situation. Okay? When we're trying to establish a relationship between a high score and female physics and math, what are we trying to establish here? Are we trying to establish whether women who get high marks in physics and math will lead to a high score, or whether women who achieve, say, marks, specific marks in physics and math lead to a low score, low value of high score, means no, it was not a high score. What are we trying to deduce in here? We can only model for one of those possibilities. We can either model whether these variables contribute to an actual high score, or whether these variables contribute to not an actual high score, either 0 or 1. By descending here, it simply means I'm trying to predict the yes one, that one value, one, one, because descending may that comes first. If you sort also descending may that comes one comes first, right? That is what I'm trying to predict here. So I'm trying, if I delete this, let's say descending thing here, okay, see what happens. See what happens here. So firstly, just see this thing changes here. Probability model is high score is equals to 0. This means now it is trying to predict whether these three variables lead to not a high score. Because high score value is equal to 0 meant it is not a high score. This is what it tried to establish, whether these three variables lead to not having a high score. And you can see here now, in this specific case, the values still pretty much remain the same, the intercept values and the p values. But I suppose there's a bit of a change in these estimates, which are listed here. There's a bit of a change in these estimates, though the p values still remain the same. If the p values tells you yes, these three variables do still account for whether a person would get a low score or high score, but I think the intercepts are a bit different. You can maybe verify it later on. But this is what you always need to remember in logistic regression. I would suggest you always choose the word descending, okay? Because whatever you're trying to model in your let's say data set, imagine that instead of PCM score, this high score was he getting a heart disease. Simple. So 0 meant not getting a heart disease, and 1 means getting a heart disease. Simple, right? So whatever you would make up in your logistic regression thing, right? By writing descending, you will assure that you're predicting that you would get a heart disease basis the contributing factors. This is all that means. Okay. So does everybody understand this part also? What does descending and not writing descending means? Does everybody get this part? All right, great. So I think you know what I mean. This was all about the logistic regression part. In fact, this is also about the linear regression part. You notice these things are relatively very simple to write. It's very simple to denote them in SAS. It's just like the way we're writing it in math. If this is y and this is x1, x2, x3, we just need to find out the values m1, m2, and m3, which are invisible values. Yeah, pretty much. This is pretty much simple. And I can tell you that in other programming languages, it's not that simple to write these things. Now, what you need to do at your own dispense also is that there are a lot of open source data sets available across the web, right, which are very much suited for doing this kind of analysis. It's very suited for doing all of this. Now, what you need to find out is is there a relationship between them or not? Okay, this is a very interesting thing. One of my friends was telling me about it. Uh, there was a very interesting thing which was telling me about it is it said he always observes this thing. I don't know much about the IPL players or whatever. He says I'm forgetting the name of the specific individual. Let's assume it was Sachin. Okay, let's assume it is Sachin. So whenever Sachin plays for Team India, let's say, okay, India wins. Okay, getting it? These kind of things can be solved using logistic regression. Getting it? So you can create a variable anywhere somehow. So we're just trying to establish a relationship that does having Sachin on the team, let's say, makes India win or not. Again, it is yes or no kind of a situation. So we were trying to establish a relationship between presence of Sachin and Team India winning. You can create a logistic regression equation out of it and find out whether that does impacts it or not. Okay. So these are the kind of things which you can solve over there. Or let's say another good example from stock market which I can give you is let's say whenever let's say Infosys stocks are down, okay, then the stock market crashes. Simple. Let's say if I just want to, if somebody's telling me I have a hunch, I have an assumption, as Kiru rightly pointed out in the beginning. It is an assumption whether Infosys stock value right influences the overall stock market. Let's say it is an assumption. You can deduce it using logistic regression by finding out that you can in one variable you can have the share market price of Infosys, okay, and in another variable you can have simply whether the stock market crashed when it reached that value or it did not crash, well, 0 or 1. That's it, and you can go on to find up a value basis that using logistic regression. All right, that is a good example of logistic regression. You can find out these examples as much as you want. In contrast to this, as a concluding example which I can give you is, in the linear regression, if you have to use the same example in terms of linear regression, what you would have done is, if Sachin plays for in a cricket match, then what are the scores, what are the eventual runs scored by Team India? That is the case of linear regression. Getting it? Because that eventual run scored is a continuous variable. It could be anything between 1 to 450, I guess. That is the highest run scored by, I think, South Africa. 454 it was, I remember, against Australia. It could be any value between those things. That is linear regression. In the case of stock market, if you're trying to predict what is the relationship between the Sensex, okay, what is the relationship between the value of Sensex and Infosys share value, then it is a case of linear regression again, because you're predicting the Sensex value can be anything, right? And the Infosys value could be, let's say, anything. That is what we're trying to predict. But if you're trying to predict whether Sensex will crash, whether the Lal Street will become Halal Street, whether it will become that or not, then that is logistic regression. Okay, so just remember, whenever the outcome is binary, dual in nature, okay, it's one of the very few outcomes, then go for logistic. Okay, if it is continuous in nature, then you go for linear regression. Okay, so I think this is all about linear logistic regression. This pretty much wraps up everything which we had to discuss about the linear logistic regression. Okay, let's head out for a break right now for 10 minutes exact, and after that I can take up more questions from all of you basis the linear regression or the logistic regression if you want something specific to be understood. Okay. After that, we continue on discussing about the capstone project, that what do I expect from you and what are you expected to build in the capstone project. Okay. So it's 11:34 right now. Let's return back at 11:45 a.m. All right. So guys, I'm back. So let's proceed ahead with any questions anybody might have. Any specific questions anybody wants to ask right now about anything? All right, ठीक है. All right. So I presume so if there are no more questions of this, then this is a consider this as an epic ending to all of the things which you started in a lot of months before trying to understand SAS about everything. Okay. Uh, uh, it's pretty much all of this. I hope we were able to make it as good as possible as you wanted. But still, the part from digital media doesn't really end here. You are lifelong students of ours, and you can still, communicate to us on the LMS, and you can still ask questions on that. At the end of the session, I will also be giving away my personal contact number and email address if anybody wants to, let's say, speak personally, speak one to one, or discuss anything about the career, anything they can also discuss about that. Okay, so this is all about it. So also just get onto that codes which I've just given over to you. There are a lot of files in that. You can take them as a reference whenever you want to understand anything specific related to any specific topic. They're always available. They're nicely documented codes by me. And like I said before, they're all my personal codes, something which you'll not find on the LMS, something which I built myself to make it easier for me to explain things as on the session. Use them all, along with each other. Okay, so this is all about it. Let's proceed on to the last leg of the last leg of this engagement between Digital Vidya and you all. So it is the capstone project that you all need to be that you need to work upon. So let me just describe to you how this thing is typically going to go forward. So it is today's class, and there are subsequently two more classes available to all of you to discuss about the capstone project. In this capstone project, none of these classes need not go till 3 hours. Firstly, this is the first thing, because it is going to be mostly as much we can discuss about the topic at hand. We will discuss, but I know there is not much worthwhileness in discussing it till 3 hours, uselessly stretching it towards it. So this capstone project is more of like an assignment given to you, a big assignment, right? Which you have to perform. Okay. So all of these sessions are that they will be driven by you all. Okay, not by me. Okay, not by the tutor, but by the participants. In this case, it is driven by you all. So it is you who is going to be writing codes. You will be the people who will be coming back with solutions and questions, and I will be answering all of those things. I will not be teaching anything specific, anything new in all of this, but my job would be to answer your questions, any brief, any specific, or any in a brief thing which you might not have understood in writing those SAS codes which we have discussed till now. Okay, so make it very specific. It is you who will be driving these three classes, not me. So it has to be this way. By the very definition of a capstone, capstone is not really the name of the project. It's a term used in the education industry, where a project is given to the participants at the end, and they have to complete, and the tutor or the educator in this, right, has to preside over to all of you and solve all of your problems. Okay, this is the way it's going to be putting out as. So in the subsequent sessions, also the next two of the one which we have, anything which we discussed in these sessions, you have to write codes, and I will be making you all presenter one by one. You will be required to present the code which you have written, okay, to all of the people, and then we will discuss about what have you written as code, and what are the problems you faced while writing up all of the code, and what can be done to solve those problems which you might be facing over there. So you will be becoming the presenters in the upcoming classes also. All right. So this is the way the capstone has in entirety. It will be run forward to all of you. Now, uh, let's discuss about what is there in the capstone project, and what do you really need to do about it. So the capstone project, which you will find out in the LMS also, or you can refer to this specific URL which is available on Kaggle. It is this data set which has been used and has been given over to you as the capstone project. I'm just sharing up the link with all of you. This is the link. Let me just load. Yeah. So this is the data set which has been used for the capstone project. It is a data set for fraud detection, and it's actually a data set which has been generated using a simulator called the PaySim money simulator. Now, what I can tell you about this PaySim simulator is all the information that is available over the internet. Firstly, it is the largest financial data which is available on the internet. Okay, and this data set is kind of a real one, but most of the data values in this have been anonymized because you cannot really leak the names of the people or the transactions they did, to whom the transactions did, publicly. You have to anonymize all of those names and the values over there. So what you would see here is there are a number of variables available to us in this PaySim dataset. Okay, they range from simply the type of the transaction which took place, whether it was a cash in, cash out, debit, payment, transfer, things like that, and what was the name of the person, right, who was originating that transfer. Okay, it is an anonymized number in this case, anonymized. You will not be able to identify directly who the person with their email address or their specific name in some in the world was over there. Okay, and it will also tell you whom the person was transacting to here, the name destination here. And then you will also find out two more variables here, is fraud and is flagged fraud. So these are the two variables which are already there, and the purpose of these two variables is that is fraud variable tells you that that transaction was actually fraud. Okay, but it will not tell you how is it fraud. Alright, it will not tell you. It will just add the people, the PaySim organization, when they were doing the transactions, they deduced that this is a fraud transaction, and they also flagged some of the transaction as possibly fraud. Okay, so in this, the difference between these two variables is that in the real time, as this thing happens, right, you would also notice in the normal day-to-day transactions as you do over the credit card or you do using net banking or other things, right? Some of the times it may have happened to you that you did a very big purchase, okay, in some specific city, maybe a lakh of rupees using credit card, and you might immediately get a call from your specific bank asking you that, sir or ma'am, is this the transaction which you actually did or you didn't do, right? So in that case, it is when the transaction was happening, it was flagged as fraud, okay, and there was an automated message generated from the your bank side asking you whether, sir, did you actually did this transaction or not, and only after you've said you've done the transaction, this flag is removed. Otherwise, if you said this was a transaction not done by you and this is a fraudulent transaction being done by somebody else, this is flagged fraud, right? Is then shifted to is fraud, that this was actually a fraud transaction and should be blocked, by the way. Okay, so this is the difference between the two. Is fraud is we know it is fraud. Is flagged fraud is it could possibly be fraud, and further investigation needs to be done on whether this transaction which has happened is possibly fraud or not. All right. Then you will find some other variables also over here in this data set, right? I'll go through one of them one by one through all of them, and so that we can understand it. This is the most important variable in the whole data set in my regard. This step variable, it maps a unit of time in the real world. In this case, one step is 1 hour of the time. The total steps are 744. So it's 30 days of data, which is available to us in all of this. So the values of step in this data set will range from 1 to 744. Okay. The values of step will range from 1 to 744, and each value of step 1, 2, 3, or 4, they represent a specific hour in which that transaction was happening. So let's assume that this is the data set which began from 1st January 2018. So this whole data set is ranging from 1st January 2018 to 30th January 2018. And the step value of 4 means that it is the 4th hour on 1st of Jan 2018. So as the new year began after 31st of December last year, right? So at 4 a.m., between 4 a.m. to 5 a.m., sorry, between 3 a.m. to 4 a.m., all of the transactions which were happening over there, 3 a.m. to 4 a.m. के बीच में जितने transactions थी, they have been labeled with 4 because it was the 4th hour of that day when the transaction was happening. So you will notice it is 30 days of simulation in which the whole thing is occurred because it ranges for 30 days. All right. The type of the variable in this case, as I explained to you, it is fairly simple. It simply tells you which kind of transaction was occurring, whether it was a cash in, maybe somebody deposited the money into the account. The cash out means somebody withdrew the money from the account, means it was an ATM transaction. Whether it was a debit simply means somebody swiped their card, or maybe somebody transferred money to somebody else. And the payment means in this case, you bought something over the web. Okay, you bought something over the web and a payment was made to a specific merchant in this case. The transfer is very similar to the debit thing in this, but debit is more of like the 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 debit is more of like the transfer is in this case more of like you're transferring money from one individual to the another. Debit could have many reasons. Debit could be I mean it could be it could what in what all cases do we get debit, by the way? So money gets debited from our account, let's say because of the charges which the bank applies on us. So maybe an annual maintenance charge. They say the 500 rupees is usually deducted from everybody's account every year as the insurance, the Prime Minister insurance yojana. I think there is something called that. So that is a debit transaction. So you've not really purchased anything. It's a normal debit which is happening. Maybe there's some taxes levied by your bank on your account. So then also they will deduct money from your account. So that's a debit. You're not transferring money. You're not paying anything. It is not cash out. It is not cash in. It's simply a debit. So it's those kind of transactions which are listed over there. The amount is definitely in this case is the amount of transaction in the local currency. It simply says how much value of money was, let's say, transferred, let's say, transacted in that specific transaction. So the type of transaction could be any one of them, but how much money was transacted in this case. The name origin, as I told you, right, it is the alienated, the anonymized name of the person who did the transaction. And you might ask you, why are we anonymizing the data sets in this? Now, I need not explain to you how major data security has become these days, isn't it? Facebook has been through a very major controversy right now. There was a data leak which happened of individual profiles to specific organization, and they used that data to manipulate the US elections. And in fact, there has been like good reports that even the Indian elections were manipulated. There were specific political parties in India who requested that data, and when the data came out, they were able to predict that which kind of what is the personality of that end individual. So what is the personality of the end individual, and they were able to deduce whether this person is going to vote for BJP, whether it's going to vote for Congress, whether it's going to vote for TDP or any other individual. I'll describe to you that data security part in a while also about this. Also, there is a very major controversy brewing about Paytm right now. So there was a sting operation, if you would have heard about it, Operation 136, right? A sting operation on multiple media houses that they might be willing to put up specific content on the websites or the newspapers for money. And Paytm has been accused and there's a sting operation has been recorded on video that they gave the data of what you transacted on Paytm and everything which you do on Paytm to Prime Minister's office. They gave away the data to Prime Minister's office, basically, not without your permission, by the way. So they did all of that. So it's a controversy. So they need to alienate the data. If the financial transactions have to come up in the public, they cannot tell you who did it. They cannot tell you Dilnoor did it, or Kiru did it, or Vipul did it, or Saurabh did it. They cannot tell that. They will just give a number, maybe XYZ or 1, 2, 3, 4, 5, but they will not tell the name of the person or the email address or the phone number of the person. So you will find these alienated numbers over here, anonymized. The other thing is about the old balance or orange simply means initial balance before the transaction happened and a new balance is after the transaction which happened. Now, usually this will have a relationship. This will have a relationship between type and the old balance and the new orange. You can drop those regression equations here. You can even find correlation between proc core here. You will find a relationship between this type and old balance and new balance coming up because, in fact, around the amount also. Because if it is a cash in, for example, yet okay, so your new balance will be more than the initial balance. Simple. If it is a cash out, then the reverse is true. If it is cash out, the new balance would be less as compared to your initial balance. This is all what is happening in all of these transactions. Now, these two variables, they could have been done away with, I also believe, because the amount pretty much tells you about the whole bad difference in the transaction. But this old balance and new balance orange is, kind of important because it will help you identify those bugs, software bugs in which these could be pretty much handy. Because once you start the exploratory data analysis of the data set, right, you would notice that the new that there are some inconsistencies in this old balance and new balance orange. That whether when you're doing cash in, for example, you expect the new balance to be more than the old balance, but it will not be the case in certain transactions. So you'll have to find out those incorrect values also, because they are also reflective of that maybe somebody manually fudged the data. Okay, somebody has manually gone onto your database and edited those values after that. Okay, or maybe a software bug is doing this. So recently I had this very weird experience with HDFC, my bank, right? So it was a software bug which was the cause of all of this. So I have a credit card of HDFC, and so ki when you get these credit cards, you generate points over the period of time, isn't it? So you get those points over the period of time. Now, when you get those points, I had collected over the past year 1,000 points, 1,019 points to be precise, and I saw simply an option to redeem those points as cash. Okay, so I was simply looking, there's a way of redeeming those cash. To my surprise, those 1,019 points were equal to 10,190 rupees. Okay, I was very happy. All right, I was very happy that my 1,019 points value at 10,190 rupees. So without looking anything, without doing anything, I simply reimbursed all of that points, right? And in one day, I got 10,190 rupees into my credit card account as a redemption of the points which I had made. But I think they somehow understood it is a software bug which is doing all of this. So they took away the amount and then put 1,019 rupees into my account. Getting it? So 1,019 points equaled 1,019 rupees actually. Mistakenly, a bug was causing it to give it a multiplicative factor of 10 there. So these are the kind of problems, these are the kind of things which get, they're not exactly fraud, but they're kind of mistakes or bugs or whatever. And they are somehow corrected by, you need to find out those possible glitches in the system also. You can find out using old balance origin, new balance origin sets. Okay. Then it is the name destination, which tells you the customer to, which was a recipient of the transaction, whom did you transact to? So if you transferred the money to a friend of yours, that is the name destination. If it was a payment done to let's say a telecom provider for your telephone bill, then it's the name destination of that person. Then it is the same thing for the old balance of the destination and new balance of the destination. It again tells you the same kind of thing. So you can apply the same kind of checks which you applied here over here also. And like I told you, is flagged fraud and is flagged fraud, right? What is the importance and the meaning of these two variables? Okay, so this is all of our data set which we have here. And what you would also notice is there are 10 lakh observations which are available to you in this data set. 10 lakh observations. 10 lakh is a huge is a huge amount, and most of what the very first problem which every one of you is going to face while dealing with this data set is it's going to take a lot of time to run any of this proc, prec or proc means which we've been very easily be able to run now. So when you deal with such a big level of data, right, the things are going to be of a bit of a problematic in nature. Okay, so another problem which you are going to face is that when you are going to be doing analysis on this, okay, you are going to you will face up a problem how to import that CSV file into your SAS environment. Okay, this is the first problem which you're going to face. When you will be downloading this information, you can download this. This is 182 MBs, and you can also download the same information from the LMS also if you want to. You can download that information, and this information will be beyond the size which SAS can tackle. SAS will give you an error that if you want to import this CSV file into your SAS environment, as Akash would have already told you, what you do is you need to go onto a folder. Okay, let's say airplane data, let's say capstone. Then you right click onto it, and then you click this upload files, and then you go on to select that specific file. Okay, and then you're able to let's say import that file into the data set. That is how you have been doing it till now. But it is going to throw you an error that SAS only supports import of only 10 MB big files only, and not any more bigger files. So 182 MBs is definitely far more bigger than 10 MBs. So how are you going to still import it? That is what I'm going to describe to you. So do look it closely, because I got a lot of queries regarding this. So I just want at least you understand it how it needs to be done properly. So maybe this is part of the very first or second sessions where he would have explained to you, Akash, that how to use this my folders concept over here. How to use this specific linked folder in SAS. This is my folders. This is not just my folders, but my folders is this one. How do you link this folder to an actual folder in your data set? He would have told you here, but if you forgot it, let me just describe it to you once again. So when you will be launching this VMware at your own end, okay, let me just describe it to you. So when you will launch this virtual machine at your own end, so when you will launch this virtual machine at your own end, it will possibly give you a pop-up like this, okay? Or maybe depending upon your workstation, whichever you are using, it might give you a different pop-up. We need to go on to the SAS thing which you launch here, okay? And then go on to this edit virtual machine settings, which you can get from here, right? Or you can click on this settings button here also by right clicking onto SAS. When you go to edit virtual machine settings, it will open up something like this, okay? Then you need to go on to options, okay? And this is the thing which I'm speaking about. This is your working directory, where I have mapped this specific folders, the specific folder in my C drive here. Okay, specific folder. If you would have not mapped it, you can change it by clicking on the browse button if you have not mapped it already. But in my case, this is the folder which I had mapped here. Okay, C next level SAS. This is what I've mapped here. And what you need to do now is that just trace that folder in your C drive here. Okay, in this case C drive next level, and then you go to SAS, and this is my project in which this is the one which I mapped here. So put the CSV file in this folder, whichever you mapped there, C next level SAS, like the one which I mapped. You can have your own folder. You just need to put the CSV file here, and after that what you would notice is that all of that file will now be available to you in this specific folder here, right here under these folder shortcuts. That CSV file will be available to you here. Okay, and after you've done that, then you need to go on to this simple, that either you can use the in-file statement, right, which you have used there, but I kind of don't really like that part not much, because it's a bit of a tedious in nature. So I simply use this new import data option which is available to us. So click into this new import data, and it will ask you for the file which you want to import here, and simply just select the file from which you would have downloaded here. Specifically, let's say in this one, in this specific one, I would have, let's say, chosen for this one, SAS data, and then press open, and then simply press the run button. That's it. All of the information which is available to you will be imported directly into, will be imported to you directly into the work folder here. In the name of work.import, it will be imported into this work library, which is available to you, into a new data set, and then you can start playing with that data set the way you want. Okay, so this is the first hurdle which you might have faced, but let's say I'm just solved it. You need to map that specific folder with an actual folder in your Windows machine. That data in that folder will be available to you here in this folder here at the top, and then you can simply need to go to the new import data and then import that data, and then you're done. It's 1 million approximately observations, 10 lakh specifically, which is a huge data set, and it's not something which it is going to take a lot of time to run your analysis on all of those data sets. Remember, okay, it's going to take you a lot of time, but that is what the intention of the whole thing is. I want you to experience what it really feels like working in the SAS environment, and how important it is to write those optimized queries, the good queries of doing these things. This is what I would really want, and encourage everybody to look into it. Okay, so feel the frustration as you do it, but that is the real stuff. Imagine when I used to run some of my codes, they used to run for 3 days. I remember running my code on Fridays and expecting that when I come back on Monday, the code would have run and given me the results. Because when you deal with such big data sets, right, it's going to take a lot of time for things to slowly go by. Okay, so this is the first hurdle. So all of this, after you import all of this data set into your environment, right, then I would say the possibilities are limitless, and you can do a lot of analysis on all of this data set as the way you want to. Now let me tell you what do I expect from all of this, let's say the exercise which we're going to do right now. Okay. Now, you know what, we're going to do it step by step. Okay. This is a fraud data set. It tells you ki, the fraudulent which of the possible variables are possibly fraud, which of the transaction are possibly fraud. Now, it could be the case, we're going to do it in two steps right now. Okay. The first step is that we're going to do the exploratory data analysis, which I would suggest should take up more than 75% of your total capstone. That is what I would like to see. Okay. The first step is do the exploratory data analysis of all of this. Find up as much relationships as you can find out within these variables. And as you do, okay, after we after I'm content with everybody having performed the EDA on this data set, right, then we move into understanding what are the possible ways in which fraud is committed. Now, as we discuss about the ways in which possibly frauds are committed, do understand there are two possibilities after this. The first possibility is कि when you detect कि whether a row is fraudulent or not, your value might match with this is fraud. Okay, then you might be bang on so right in deducing that this transaction, depending upon the values here and there, right, it is so good that your value matches to is fraud. Okay, then it's a very good answer which you were able to reduce. But there may be some cases that your values, the one which you'll be labeling as fraud, okay, might be different from the one which they have already labeled as. Okay, it might be different from that part. In that case, don't think you've reached up an incorrect answer. Think that you might have possibly found out a fraudulent row which they themselves were not able to find out. Okay, they themselves were not able to find out. This is very good stuff, right? And we will be discussing about these things about which is fraud and which is not fraud. The ways in which you detect fraud, like what are the, let's say, the top 5 ways in which fraud is detected or committed in the first place. We will be discussing about those strategies, those normal human strategies which humans apply. And then once we discuss about those strategies, we will be discussing about how can we use that knowledge, right, to convert it into an algorithm. And then how do we convert the algorithm into actual SAS code? And once we actually SAS code, how do those we end up as, how do we deduce whether this is a fraudulent transaction or not? So this part specifically this part should be approximately 25% of all of your submission about the capstone project. Okay, this is what I want. Now, for the next session, as we have by, uh, I want to lay down what do I expect from every one of you, what is there in this data set. Let me put up an expectation right away. So, in all of the data set which we have right now, I've already shared with you the codes which I've written, today, the link which I shared with you. Okay, you will find this specific file there called EDA. It will have this file named EDA, Exploratory Data Analysis. It will have all of the procedures which we have used till now to create a training testing, then proc data sets, then proc preg, then proc mean, then proc SG plot, then proc reg, and even proc core and proc logistic also. All of it is already there. Okay. What I would encourage you is that you run this EDA on every single variable which is there in the data set. Okay, getting it? So not the proc reg or the proc core or proc logistic, because you know that these three procedures, right, are run on minimum 2 variables. The proc correlation, the logistic regression, or the linear regression is there to find relationship between variables. You're not reaching that stage first. Firstly, just run all of the other procedures of proc preg, proc means, proc SD, maybe proc SD plot can also be used, proc dataset, proc contents, everything else on every single observation, which every single variable which you have over there. Okay, so this is the first step. This is what I would want you to do first. Okay. Second thing is, I want you to run this correlation analysis, or the, let's say, the linear regression analysis on the logistic regression analysis across variables. This is what I would want here. Okay. So in this case, just try to understand is fraud is again logistic in nature. There are just two possibilities. Is it fraud or is it not fraud? Simple, right? So the whole fraud analytics industry, understand, it is a logistic regression driven industry. It's completely that. Now what you need to find out is just try fitting this is fraud variable using proc logistic with the rest of the variables here. Just try to fit in. Just try to find out is there a relationship? Is there a relationship between any of the other variables and is fraud variable? And that the p-values will tell you that. You know that the p-values will tell you that. Now we're trying to find a relationship between variables. That will be interesting. So I would want by the next time everybody should have done this. Okay, they should run this back. The last thing which I would want everyone you to very closely understand is कि for me, framing the right question is very important. This is the first thing which I told you when we had the first class in statistics, when we discussed about the airplane example, like where should you armor where should you shield the aircraft. Whenever you write code, right, you should not be writing the code blindly. Okay? What I would expect from all of you in the next class is that you tell me why have you written that code? What were you trying to deduce in that specific code that led you to do that? Okay? What was the specific thing here? So what I expect is, for example, that when you run, let's say proc means here. Once you run proc means, right, one possibility is you run proc means only on the step variable. Okay? Understood? It's very simple. You write proc means data is equals to this data set, right? Then var step, then run. You'll be able to understand what are the statistical properties of the step variable. But what I would also encourage you to do is try grouping it using other variables. What I would like to know is there are so many interesting things which you can find out using just this information. It is unbelievable. It's unfathomable. It's only in your own imagination which you can use, which is limited by that. So, for example, by using in proc means, okay, by using proc means on the step variable and using type variable in the class statement, okay. So by doing something like this, let's say proc means data is equals to whatever data set you import it into, then you write var step, then class type, then run. Do you know this is such important level of information which you can draw up in this EDA. What this will tell you is that this will group the transactions, okay, basis the type of transactions that happened. So it will tell you ki every single day how many types of transactions were happening. It will tell you how many number of them, what was the mean value of them, what was the median value, what is the standard deviation, and what were all of those. So by this, you can actually find out whether there are specific hours, okay, whether there are specific hours in which certain type of transactions happen the most. Isn't this such a valuable information? Right now, don't focus on fraud or anything at all. Just focus on what more information, what insights can you draw from this data set? What all possible insights can you draw from it? By using such kind of a possibility, we can know that. Or if I were to simply exchange this, let's say I were to do this type here and then replace it using step here. So what this will now tell me is every single hour in which the data set is laid out into, what were the type of transactions that were happening in that specific hour. Getting it? This will tell you that. Now because it is grouped by step, now it will tell you every hour what were the types of transactions which were happening. So what you would notice is those step values, okay, which fall at night. Okay. So for example, step value of 2 is 2 a.m. at night. Step value of 26 is again 2 a.m. at night. Step value of 50 is again 2 a.m. at night. ठीक है उस केस के अंदर you will see that the type of transactions which are happening are usually not payments. You're not buying anything at that point. You're not, there will be very less cash out transactions at that point because not many people are using ATMs at 2 a.m. at night. Not many people would be doing cash ins also. It's possibly maybe an emergency case that a mother is sending money to her son because he's met with an accident. Transfers will be the most one will be showing up over here. Maybe. This is what you need to find out. So you need to find out insights from the whole data set, right? Just consider it raw data and find out what are the relationships within the variables and across the variables. That is what I want. That is what I would really, really want everybody to find out. Yeah. So you're right about this, Kiru. In the var variable, since the proc means only runs on the numeric variables, right? So in that case, the type will not be this one. The type will not be used because in that case the values are let's say text in nature. So it cannot give you the statistical properties in this. But I was just taking an example. I was not really thinking of what are the type of data inside it. But yes, the proc means can only be run on numeric variables. So that is what you can use there. Okay. So you can also do one more thing that instead of these four values: cash in, cash out, debit, and five values, right? You can choose them as one, two, three, four, and five. Maybe then when you transform them into a numeric variable, it might give you a different answer that might be useful to us. But you know, it is right that you cannot use a type variable as it is in this equation. I'm sorry for doing it this way, but yes, this was more of like an example. I was not really thinking about the underlying values. Okay. So what more information which you can also find out is ki in this name orange, for example, you can also use it as something like this. So in this case, what it will tell you is that name origin, this person, specific people, right? What are the times at which they usually transact? This will also tell you this kind of information about it. So there might be some people who do all the transactions at night. There might be those shady examples. There might be, withdrawing money right at night, maybe out of a stolen ATM or whatever. You might doing this. But like I said, the possibilities are limitless. So what I expect from you in the next class is that this you have to find out firstly the relationships within the variable by running your proc data sets, frac, means, and other things. You can then try to find out relationships across the variables by using core linear regression or logistic regression. Find out that. And also on top of all of this, okay, you need to tell me why. This why thing is very important. Why are you writing that line of code which you are writing? Simple. I just need to know why. Why have you framed that? Why is that question? Why answering that question is so important to you that you've written code for that thing? That is what I'm most interested in knowing about it. Okay. So these three things should be up. These three things are something which I expect from every one of you in the next session. I will make every one of you presenter in the next session so that you can demonstrate all of your code. And we'll spend about the initial 1 hour or 1.5 hours or so discussing about codes which you all have written, which I hope you should write. And after that, we will be discussing about some ways in which fraud is typically committed. And the last session, right, we will be discussing about the codes which you've written about how to detect that fraud to some extent. Okay. So in the last session will be about matching whether our variables of fraud, right, match with that of the is fraud or not. That is what the purpose is. But do remember, for me, EDA is the most important part. EDA is the most important part because that is the gateway to anything. It could be fraud, it could be it could be profit loss analysis, it could be customer acquisition analysis. If you do the EDA right, anything after that is possible. This is the reason I would want you to stress the most upon the EDA part. Write as much code as possible for EDA, and then lastly we will we will write up some codes. Not those swanky and very advanced level of fraud analysis, which obviously takes years to understand and maybe master. We'll discuss about the typical ways in which the frauds are detected in the world, the best ways in which they have traditionally been detected, and how SAS can help us into it. Okay, so we'll keep it simple. I don't want to make this thing extremely tough. कोई submission in आया हमारा. I want this you be able to submit this. So EDA is 75% of the submission. Remember this. All right. ठीक है. तो बस यही है. Is there any question anybody wants to ask in all the things which you need to do for next time? Is there anything specific? See, I would suggest you start the capstone, Kiru. I would suggest maybe you can keep on doing the assignments. You still have a couple of more weeks, maybe like 3 or 4 weeks for the submission of everything. So in that time, you can complete the rest of the assignments and maybe the capstone project also. All right. So any specific question anybody wants to ask? All right. So if so is the case, so just sharing up the feedback link with all of you people. I would be really, really looking forward for all of you to do the EDA part very nicely. Okay, and I would also request everybody to actually attend all of the capstone projects because it's kind of interesting, the fraud analytics part, and it's a lot of exercise which you can do at your own end in fraud analytics, and it's a great value addition to your career because a lot of terminology, a lot of ways which we'll discuss about how fraud is committed. Right? If you are in an interview with a financial organization, you can tell them that you worked on an experimental project, right, which is what about fraud analytics. And this is one of those projects which not many, let's say, many organizations take up. They take up those IPL examples, IPL के अंदर, but I don't like those examples because they're not practical. There's not even a single company on earth, right, which uh, which predicts who is going to win in the IPL matches. Nobody. It's only the bookies doing it, and they don't use data analytics. They buy players to do it. Yeah. But in fraud analytics, right, that is actually an industry out there. Actually, an industry out there which does fraud analytics. It's a huge industry, billions of dollars of industry. So these examples are very practical in nature, and these are the same variables which you deal with in actual fraud analytics industry. Also, there will be a career edition instead of things like IPL scores or IPL batting averages or whatever. Right? They're not practical. They're good examples, but not something which you can take away into your career. So this is the reason I chose this specific thing. And you can also take cues from people who have already solved the fraud detection part here in this website. So we look at this discussion here about this data set. There's a lot of people who have already done this EDA part and fraud detection. You would see this, right? They will also ask a lot of questions, ED and fraud detection. So they've already done these things, but they have done that using Python and R. Okay? Because this Kaggle dataset, Kaggle website, right, doesn't allow, because SAS is not open source basically. Okay? So they cannot integrate SAS into Kaggle. They can only integrate Python or R because they're open source. So you will see a lot of people do solving these things using R and Python. What you need to find out is what kind of questions have they solved. Okay? What kind of questions have they solved? That is more important, not in how you do it. So you can even do this fraud analysis in Excel if you want to. It'll take a lot of time though. Okay, it doesn't matter in which program you solve it. It's just that what are you trying to solve, which is most important. So you can take some cues from things like this. Okay, all right. So just sharing the feedback link with everybody. I mean, if you have any problems, right? I'm just sharing my email address and a phone number with all of you. I think I probably shared it with you before also. I don't know. Maybe I forgot. I forget a lot of things sometimes. Um, you can contact me, right, if you're facing some specific problem in Capstone or like any journal thing you want to ask, like at the conclusion of all of this SAS training and everything, anything related to your career, maybe what lies next, maybe anything you want to understand specifically related to SAS or the world out there in data analytics. I've been into this industry for the past 7 years. So, kind of know enough, if not lot. So please contact me. I'm open. If I'll not be able to immediately answer your call, possibly we can schedule up a call at some time. We can discuss about it. Okay. So this is all about it, people. Okay. So if there are no more questions, we can end the session right now. All right, ठीक है, people. All right, ठीक है. So it was have a great weekend, everybody. And I mean, let's meet back like 1 week from now, and like let's discuss a lot of possibilities there in this data set. ठीक है. All right, ठीक है. Thank you. Bye bye.